Alright, so this is number 11 on the practice test where it says, when the equation above is balanced, all coefficients reduced to the lowest whole number states the coefficient for H2O is. So what they really want you to do is just to balance the whole redox reaction. So you have to go through and do all the steps. And so I'll go through and do all the steps for this one, and then I'll refer back to number 11 if people are stuck on balancing redox reactions. So step number 1 is to assign oxidation numbers. And so I'll go through and do that right now. This is -2. That means nitrogen's got to be +3 because it's got to add up to -1. Oxygen's here -2. Times 7 is -14, so that means chromium here must be +6. Chromium over here is +3. Oxygen over here is -2. That means nitrogen must be +5 because it's got to add up to -1, and there's 3 of those -2s. Oxygen here is -2, and hydrogen here is +1. So that's step number 1. Once you assign the oxidation numbers, you need to split it into half reactions. And so the split half reactions are to first decide which things oxidized and which things reduced. And so my species that is going down in charge right here is chromium from +6 to +3. And so I'll write that as my reduction half reaction. So Cr2O7 to minus goes to Cr+3. And then my oxidation half reaction is going to be the one where nitrogen goes from +3 to +5. That one goes up in charge, and so it's oxidized. So NO2 minus, arrow, NO3 minus. Now I know there's a bunch of hydrogens and oxygens in there which are going to end up appearing as I balance the reaction. You can try to put them in someplace, but you don't know exactly where until you go through and balance the whole redox reaction. So once I've split them up into half reactions, now number 2 I need to do the balancing parts. And the first thing that I do is I balance everything else except hydrogen and oxygen. And so I need to balance my chromiums here by putting a 2 right there. And then the nitrogens, of course, are already balanced. And then I just have oxygens remaining. So then I balance oxygens with H2O because all these solutions all these reactions happen in aqueous solution. You can see AQ down below here. So there's a lot of water available to help balance a reaction. And so on this one, I'll need 7 H2Os because I have 7 oxygens right here. It's a 3 and a 2 right here, so I'll need 1 oxygen over here. So that gives me 3 oxygens on each side. And then my last step is to balance the hydrogens with H+. And so I have 14 hydrogens here right now, so I'm going to need 14 H+ on this side. And since it occurs in aqueous acidic solution, there's lots of H+ available. I have 2 hydrogens right here, so I'm going to need 2 hydrogens right here. So that takes care of that part of the balancing, except for now I'm on to balancing the charge. And so I use E minuses to balance the charge to make sure that the charge positive and negative part is the same. So adding up the charge on this side, I have +14 and -2. So that means that I have +12 on this side. And then over here I have +6. So that means I will need 6 electrons over here to get a same charge. So I'm +6 on both sides. And then in here I have +2 and -1. So I'm +1 on this side, and over here I have -1. So to get it even, I'll need 2 electrons on this side. Okay, so then step 3 is to get the electrons to be equal to each other. And so I have 6 electrons here and 2 electrons here. So I think I can end up multiplying this one by 3. I think that's how it can end up working, okay? And then this one, of course, can just stay at 6 electrons. So this changes my oxidation half reaction to be 3H2O plus 3NO2 minus, arrow, and then I get 6 electrons, and then I get 3NO3 minuses, and I get 3 times 2, or 6 H pluses right here. I got to be real careful because I got lots of little stray marks here, and I might mess up my charge, and then I have to start the whole video over. So I'm going to take a second right here to make sure that I did that right. 3, 3, 6, 3, 3 times 2 is 6. The E minuses match the E minuses. All right, step 4 then is to combo them. So I combine the half reactions and I cancel things so that it's the same on both sides. So that means this stuff is all going to combine with this stuff right here. And then this stuff is all going to combine with this stuff right here. So putting those together, we get 14 H pluses plus Cr2O7 2 minus. I'm going to cancel the 6 electrons with the 6 electrons right now, so I'm not going to rewrite those. And then I have 3 H2Os from right here and 3 NO2 minuses from right here. Now on this side, I have the 2 Cr positive 3 plus the 7 H2O from right here. And then I have the 3 NO3 minuses and the 6 H pluses right here. And now I can cancel a bunch of stuff. So I got 6 H pluses here that are going to go away, which gets me down to 8 on this side. I have 7 waters here and 3 waters here, so my 3 waters are going to go away, and then I'm going to end up with 4 H2Os right there. And then, after I've canceled those out, I have to check it, which is, well, unless it's in basic solution, that's when I have to do step 5. If it's in basic solution, then I need to get rid of the H pluses by adding OH minus, but it's not. So then in step 6, I just need to check. And so I'll go through and do my check, and I hope that it's going to work. Oh my goodness, this is a lot to do live on video. Let's see, 8 pluses right here, 2 minuses right here, and 3 minuses right here. That gives me positive 3 on this side for a charge. And then over here, I have 6 pluses right here and 3 minuses right here, so I have a total of positive 3 on this side. So for charge, it works out. Okay, good to go. Then, check for mass. 8 H's, and I have 8 H's right here, 4 times 2. 2 chromiums, 7 oxygens plus 6 times 2, so that's 13 oxygens. 4 plus 9, is 13 oxygens, so I'm good there. 3 nitrogens and 3 nitrogens. I think I made it. It looks like it's balanced. So now I can actually answer the question, which says all coefficients are reduced to their lowest whole number terms the number in front of H2O. It looks like the number in front of H2O right here is 4, which would be letter B right here. All that work to answer that one, yup, that's the kind of problem you're going to get. All right. I'm going to go on to do number 12, then I'm going to take a break and go on to the next one. Let's see, the half reaction occurring at the anode in the balanced reaction below is, so you have to go through and assign oxidation numbers, and remember the anode is oxidized, remember, an-ox. So the thing that's oxidized, the thing going up in charge is going to be our anode. So oxygen is minus 2, that means manganese here is going to be plus 7, hydrogen's plus 1, iron is 0, this manganese is plus 2, iron here is plus 3, oxygen's minus 2, and the hydrogen's plus 1. So my thing that is oxidized going up in charge is my iron going from 0 to positive 3 right here. So my half reaction would involve the 5 Fe's going to the 5 Fe plus 3's, which is going up in charge, and as my anode is my oxidation reaction. And I think I have an iron going to iron plus 3 right here in E, which would be, well, of course, needing 3 electrons right here if I reduced these 5's, because it would be a simplest whole number coefficient of 1 and 1 to balance for charge, and I'd need 3 electrons to balance the charge. All right, that's that page. We'll be back with the next video for the next page.